Welcome back to our channel. Question 8 is very good. Besides IB, I do GCA level, IL, AP, and sometimes do DSC. Okay, I found I never thought of we can discuss the thing in this way. So it's a very good question about a complex number. So first of all, look at here. First one is show that the argument of a complex number equals theta. Don't get distracted by all the thing up there. Okay. Remember what is the argument? So remember it was z equals a plus bi. So you interpret it as a cosine theta plus sine theta I, right? So interpret okay, so tangent theta will equals b over a. Bingo! That's it. Stop it. Stop it. This is the fundamental thing that we know. Tangent theta equals the imaginary part over the real part. So we start from here. Okay. So exactly. So we said that tangent to theta is the argument of tangent. The argument set equals the imaginary part sine to theta over the real part 1 plus cosine to theta. At first you don't know what to do, so just expand them. Numerator is 2 sine theta cosine theta, and the denominator you think about how to eliminate one. Yes, it is 2 cosine square theta minus 1 y cosine 2 theta. So add them together, this is 2 cosine square theta. We nearly arrive it, but it is a song question, so you need to say clearly the tangent theta. So bingo, you got it, right? So tangent argument set equal tangent theta, and the range is here. Narrow range, negative half pi to half pi, so they must be the same. So argument set equals theta. Bingo. Next one, we have to show that the magnitude, okay, the length of z equals 2 cosine square theta. Remember, Pythagoras theorem nearly, right? A square plus b square. So remember this one is a square, but a is complicated. A square plus b square. Don't know how to do it, then do something expansion, right? Expand this part, okay. This is a 1 plus 2 cosine 2 theta plus cosine square 2 theta plus sine square 2 theta. You got something, right? You got something. Cosine square sine square is 1. And then 2 plus 2 cosine 2 theta, remember here. It is a 4 cosine square theta. So it is a 4 cosine square theta. Pardon? Not 2 cosine theta. Oh, sorry. This is a z square. Magnitude square. Okay. So after this, all this thing, you can say, okay, and then take the square root for both sides. So magnitude of z modulus equals to 2 cosine theta. Bingo. Okay, for part B, hence or otherwise, find the value of theta such that argument of z square equals z cube modulus. What's that? So try to work on it again. First argument z is a theta. Okay. So what is the argument of z square? Not theta square, 2 theta. The angle, EI theta, right? And then z cube modulus, really, this cube, okay? So they check whether you understand the theory or not, okay? And then you do make some simplification. It is small cosine square theta. Okay, next step, how to solve it. Can you calculate solve it? Then we can then ask it to solve it. If you can't, I think what should you do? Plot the graph. Yeah. So plot y equals x, and then y equals 4 cosine square x, and then find their point of intersection at this range. Okay. So you really do it. Sketch it. Okay. Bring out your calculator, and then we can check. Okay. That's it. Okay. You should get this graph. Okay. The blue one. Let me get back to pen first. The blue one, the yellow one, the red one is easy. Y equals theta. Okay. The blue one is the complicated y equals 4 cosine cube theta. Sorry, it should be cube here. Okay. I should make it here. No matter how the calculator help, you can ask it to give you the point, this point, okay, point of intersection, and this is 0.913, and then after plotting them, you are sure that theta equals 0.913. Everyone know that no degree size is radian, so no need to write the unit there. You got it? Well done. Now we are moving on for question 9. See you guys.